Hello everyone, and today we will be seeing one of the problem from Geeks for Geeks. It says maximum number of ones. The problem goes like, given a binary array ARR containing only zeros and ones and an integer k, you are allowed to flip at most k zeros and ones. Find the maximum number of consecutive ones that can be obtained in the array after performing the operation at most k times. So yes, this is the one example. So where we have an array and k is 1, so they say you can flip this bit and you can get 3 consecutive ones. So for 2 you can flip either this and this, you can get this one, or else I don't think or else there is any way, but yeah, this is 1, so 5 and so on. So how can we solve this problem? How can we approach this one? So well, in naive approach, you can say that, let me take an example over here. Yeah, so in a very brute force approach, you can just say that, hey, I'll start from here, I'll check how far I can go while removing 2 characters and what is a valid string. So this can be one string, and then thereafter this can be one string, this can be one string, and so on and so forth. Ultimately you will reach at some point where you set this to this string, and meanwhile when you iterate this you will keep a count. So this is a naive approach, and again you can see this by the approach itself. You can conclude that, hey, this takes a time complexity of n square. We don't want that. So can we optimize this one? Yes, optimized. We can optimize this very well. So the problem here consists of 2 parts, I'll say. One is to convert, step 1 I'll say, to convert zeros to 1, and step 2 which says to limit your conversion till k. So yeah, these are 2 things I can see from the question itself, and with these 2 things done separately, this question is very simple. So how am I supposed to go? So while converting from 0 to 1, what are the factors you'll consider? That you wanted to consider 0 and then only will consider 1. So you can flip zeros to 1 only, that will help you, and for that you need an iterator to iterate. So iterator to iterate from 0 to n, iterator. But the only iterator won't give you sufficient window. So iterator would move, let's say, from this point till, I don't know, this, but you will not understand that where I wanted to stop. So you wanted an iterator again, so I'll say a start point and an end point, which is from 0 to n. So these are 2 points between which you will find your window, such as this. So start and end. So in this case, this would be our start, and this would be, I'll copy this example, I don't want it to mess with the brute force approach. Yeah, so in this example pointed out here, so this would be our start and this would be our end. So between this we will find our solution that is correct. Okay, so we are going from start and end, and whenever we are finding any zeros, we will convert it. There comes a step 2, we wanted to limit. Now at any point our conversion is beyond k, we wanted to not do that. That means we wanted to keep track of converted. That's cool. So yeah, and when we see converted, what is my strategy to limit? I will remove my conversions. If I'm over the budget, I'll remove my expenses. That is the simple fact. And I will remove means I'll shrink the window, and that means I'll move the start pointer. So this is my start pointer. I don't want this, so I'll remove this, move this start pointer to more and more. So if my start pointer was here, I'll remove this 0 and I'll consider this 1, and that means one flip I can ignore. So that kept in mind, let's get down into code. Few important things we need is a start pointer, is an end pointer. Initially, both start and end pointer would be at 0. That means our current window contains only one element, which is 0th element. Also we want, what do we want again? We have start, we have end. Keep track of converted. Okay, I want it to have now converted. I'll mark it as here max conversions, max conversion. Yeah, so currently I have not converted anyone, so 0, and I want it also create max, which is 0, because that's what we wanted to return, right? Max ones. So that is my return. Cool. With these things in mind, let's get started. So we have step 1, I'll copy it down here. I have step 2, I'll copy this down as well here. So now within this, I wanted to move while I'm not hitting the end. So end should be less than a dot length. And within this, let's deal with step 1. So step 1, convert. So if conversions, it should be helpful conversion, right? So if I am seeing a of end, oopsies, a of end equals to 0, and then only I'll convert it. So convert means I'll not go ahead and physically convert it, I'll just mark it that hey, I've converted this one. Yeah, I can do that conversion, but I don't want it to mess with the array initially. So converted plus equals to 1, that means I have converted this guy. Cool. So I have converted this guy. There comes step 2 now. Step 2, limit your conversions. So what I'll do over here is, while what I'm doing here is, while my conversion, which is converted amount, should be, if it is greater than your limit k, max limit, what is k, max conversion, yeah, till max conversion. So if it is greater than this, I wanted to remove this, and I wanted to check that hey, if my conversion, I wanted to what to do is shrink the window, move the start pointer. So if my start was converted, that means a of start is equal to 0, that means it was converted. So I wanted to remove that conversion. What would I do? Converted minus equals to 1. Add a conversion plus 1, remove a conversion minus 1. Simple maths. Now start, I would plus. I wanted to advance the pointer because I have already removed that start point or that start pointer from my consideration. I'm checking the next element. Cool. Let's go with, now I have a valid window. I'll go with the max. Max is equal to mat.max with current maximum to n minus start plus 1. Okay, I'll not do plus 1 right over here because start n plus plus. Yeah, because I wanted to advance the end as well. So this is it. Let me try to submit this one. Okay, cool. It is submitted with rest of all the test cases. Such kind of problems are known as sliding window algorithms. And for more such kind of content, click the video on your right, and I'll see you in the next one.